Hello everyone. Today we are going to discuss the topic of errors in measurement from class 11 physics. When we measure a physical quantity, then there may be some difference between the true value and the observed value. This is called error of measurement. There are different types of errors. Let us discuss the different types of errors. First, we have systematic errors, random errors, and gross errors. In case of systematic errors, as the meaning of the word is, the errors are in one direction only, that is, either positive or negative. And the causes of systematic errors are known. Some of the sources of systematic errors are instrumental errors, imperfection in experimental technique, that is, the procedure of taking the observation. Then the third type is personal errors. The observations vary from person to person. Then errors are due to external causes and least count errors. All these types of errors are called systematic errors. Then we have random errors. As the name is, they are random, that is, they are unpredictable, and they occur due to unpredictable circumstances. Sometimes these are also called chance errors. They can be minimized by repeating the observation a large number of times and taking the arithmetic mean of all the observations so that the mean value is close to the most accurate reading. And third type of errors is gross errors. These arise on account of carelessness of the observer. For example, reading an instrument without setting it properly, or recording the observation wrongly, or using the wrong values of the observation in the calculations, or taking the observations without caring for the source of errors and the precautions. So these are the three types of main errors that occur while taking the observations. Now the question is how these errors can be minimized. So systematic errors can be minimized by improving the experimental techniques. Selecting better instruments and removing personal errors as far as possible. Random errors can be minimized when a large number of observations are made and the mean value is taken. So, recording, observation, a number of times. Similarly, the gross errors can be minimized only when the observer is sincere enough and mentally alert to take the observations, because these errors are caused due to the carelessness of the observer. Now let us see how we calculate these errors. So first we will discuss absolute error. Absolute error is the measurement of a physical quantity, is the magnitude of the difference between true value and the individual measured value of the quantity. Now let us say that a quantity is measured n times. And the measured values are A1, A2, A3 and so on up to AN. Then the arithmetic mean of these values will be sum of all the observations divided by the total number of observations. So here I will have n. So this is the arithmetic mean, or we can simply write AM is 1 upon n sigma I is equal to 1 to n AI, where I is the index which changes up to n, that is from the first value to the last value. So this is the formula for the arithmetic mean. So the arithmetic mean is taken as the best possible true value of the quantity, if the same is not known otherwise. Now, by definition, the absolute error will be delta A1 is equal to the arithmetic mean minus the original value, that is A1 what we have measured. Similarly, delta A2 will be arithmetic mean minus the value A2, and so on up to delta AN. The absolute errors may be positive in certain cases and negative in certain other cases. This is because the observed values are likely to overestimate or underestimate the true value of the quantity. So that is how we calculate the absolute error, that is the difference in the magnitude of the true value and the individual value. Let us see how we calculate mean absolute error. So delta A mean, that is mean of the absolute values that we have calculated, will be delta A1 plus delta A2. Remember, here we are taking the modulus of the values, we are taking all the positive values here, plus up to delta AN divided by the total number of values. So the mean absolute error will be 1 upon n sigma I is equal to 1 to n delta AI. Hence, the final result of measurement may be written as A is equal to AM, that is the arithmetic mean, plus minus the absolute error, that is delta A mean. So that is how we write final result of an observation. Now let us calculate relative error. Relative error or fractional error. This is defined as the ratio of mean absolute error and the mean value. That is delta A, that is the relative error, is equal to mean absolute error upon the mean value, which is equal to delta A mean upon AM. When the relative error is expressed in percentage, we call it percentage error. That is, percentage error is equal to delta A mean upon AM into 100%. So this is how we calculate the absolute error, mean absolute error, and relative error along with the percentage error. Thank you.